Welcome to video 3. This is where we left off. We were talking about one-way ANOVA, and now we need to talk about two-way ANOVA. Two-way ANOVA is an extension of one-way ANOVA. The difference is that in one-way ANOVA, we're only considering one factor, that is, one independent variable or one grouping variable at a time. In two-way ANOVA, we are adding an additional factor. So before you feel confused, let's look at an example. The Human Resources Department at your district wants to know if teacher stress varies according to gender and teaching experience. Now we have 3 variables. We have one dependent variable, that's your stress level. We have two independent variables. The first one is gender, which we will define as 0 and 1. And then we have experience. And let's define that as novice, practicing, and master. The question we are asking now is whether stress level varies according to both gender and teaching experience, not just one or the other. We call this an interaction because we are interacting the level of experience and gender. In a two-way ANOVA, we're interested in 2 things. First, whether there's a main effect and whether there's an interaction effect. So let's break both of those down. What that means in context here is main effects. We're interested in the direct relationship between stress levels and gender. And then separately, stress levels and teaching experience and whether there's variability. With an interaction effect, we hypothesize, our research hypothesis, is that it depends on both. So for example, it might differ for women and a level of teaching experience, and it might be different for men of a different level of teaching experience. Let's continue with this example. Here are new null hypotheses. So our first one, this null hypothesis, on average, stress levels are equal across genders. That's our first main effect. Our second null hypothesis for our second main effect. On average, stress levels are equal across levels of teaching experience. And then our third one, which represents our interaction effect. On average, the 2 factors are independent or are not related. So notice that our hypothesis here is really about that interaction, that those 2 factors either interact or do not. Continuing with this example, what might results from this analysis look like? If we find a significant interaction, stress level is related to both gender and teaching level. For example, we might find that men with less experience have high levels of stress on average. Or we might find that women with middle levels of experience have lower stress on average. What might be another plausible combination? There are several. If we find a significant interaction, we do not interpret the main effects. However, if we do not find an interaction effect, then we only interpret the main effect. For example, on average, the level of stress is related to teaching experience, but not also to gender. Or, on average, the level of stress is related to gender, but not also to teaching experience. So what does this look like? This is kind of this graph lets us try to depict and hopefully clarify what I mean by an interaction. So this is an example from psychology. And you see in this table, I have on the y-axis attribution to self. And this is measuring the extent to which participants attribute success or failure to themselves. On the x-axis, I have an outcome, whether participants were successful at completing a task or not. So success or failure. And what we see on the lines is the level of self-esteem, either high self-esteem or low self-esteem. And so if we, again, take a step back and look at what's in our graph, We see attribution to self is our dependent variable, so it is continuous. And then we have the outcome being an independent variable and level of self-esteem being an independent variable. So the other factor is whether participants had low or high self-esteem. So let's break this down. What we see here is an interaction, and we know that there's an interaction because those two lines cross each other. The interaction means that the relationship is inverse, and the level of self-attribution depends both on your level of self-esteem, high versus low, and on your outcome for the task, success versus failure. The study revealed that for individuals with low self-esteem, so that's the purple or pink line, the extent to which they attributed the outcome to themselves was higher when they failed than when they succeeded. So if you have low self-esteem, you're more likely to say that failure is because of your own efforts or lack thereof. Whereas you are less likely to, or you have lower levels of attribution to yourself when you succeed. So when you do well, you're less likely to think, oh, this is because of my own efforts. On the other hand, if you have high self-esteem, we see the opposite relationship. The extent to which they attributed the outcome, success or failure, to themselves was lower when they succeeded than when they failed. So let's look, the extent, it's the reverse, sorry. So we see here that high self-esteem, they attribute their success to themselves, and they are less likely or are at lower levels attribute to themselves failures because they have high self-esteem. So the relationship between success and failure and esteem are dependent. And so the extent to which we attribute an outcome to ourselves depends in part on whether we have high or low self-esteem. That is an interaction. The two-way ANOVA has the same assumptions as a one-way ANOVA. Independence of observations, homogeneity of variance, normality. And we are still interested in partitioning variability. Here, though, we have a little bit more going on. So we have variability due to membership in Group A. That's the main effect. Variability due to membership in Group B. So that's another factor, and that's another main effect. Variability due to the interaction between variables A and B. That's our interaction effect. Variability due to differences within each group. And that is the amount of variability that is really because of chance. So partitioning, very similar, but we see those new terms there. So sum of squares total is equal to the sum of squares for factor A, sum of squares factor B, plus sum of squares interaction term, plus sum of squares within. And how do we calculate the degrees of freedom for our interaction? Okay, so we take the degrees of freedom for variable A, where J is equal to the number of levels for variable A, so that's a carryover. And we multiply that times the degree of freedom for variable B, where K equals the number of levels for variable B. So if J has 3 and K has 3, then we have 2 times 2 is 4. And what about the degrees of freedom within? Because again, we have that extra group now. So we take our total pooled sample size, so the sample size for each of our groups, and we subtract that from that the product of the number of levels for variable A times the number of levels for variable B. And if you look in the video, you will see that in the PowerPoint, that I also talk about ANOVA with 3 factors. And you can continue to add additional factors, but at that point, honestly, you really should just be doing a regression analysis because it gets more and more complicated and you have to add interactions for every single new variable you add, and it gets very complicated very quickly. So I'd say more to follow in our SPSS video. Please stay tuned. So wrapping up, ANOVA is an extension of the t-test that lets us compare across 3 or more groups. We follow a hypothesis testing process similar to the one we use for t-tests and chi-square. And our F statistic is a ratio of the amount of variability between our groups to the amount of variability within our groups. Our one-way ANOVA requires 1 categorical variable, which is our independent variable, with at least 3 categories or levels, and 1 continuous variable, which is our dependent variable. Our two-way ANOVA requires 2 categorical variables, with at least 3 categories, and 1 continuous variable. The dependent variable must meet the same assumptions as it does for the t-test. Up next, tonight, we have regression, and we'll talk about simple and multiple regression. Homework 2 is due tonight as well. Week 13, we have the beginning of our mini unit on data action plans. So now that we've done these analyses, what in the world do we do with this information? Week 14, assignment 2 is due. Please remember that that is a change. And week 15 is our poster presentation.